is similar polygons. The lesson number is 8.3. And my advice to you to have good organized notes is to be sure and include today's date with your notes. Okay? So similar polygons, lesson 8.3, and be sure and include today's date. Now, moving on. Like usual, we are going to start off with a definition. The definition that I'm about to give you is really, really important. If you don't learn this definition and understand it, then you will be behind later in this chapter. I'm going to give you the definition of similar polygons. Please do not confuse this definition with congruent polygons, which unfortunately a lot of students do, so please be careful. Copy this definition down. You are responsible for it. Similar polygons. When two polygons have corresponding congruent angles and corresponding proportional sides, then you have similar polygons, okay? Similar polygons, when two polygons have corresponding congruent angles and corresponding proportional sides. So there's two things. And please don't forget this, students. There are two things that must take place for you to have similar polygons. You must have congruent angles, and you must have proportional sides. Now, if you don't understand what that means, I'm going to explain it in just a second, okay? But make note, somewhere in your notes, you need these two things, okay? Let me give an example of similar polygons. Copy this down. Triangles are a really good polygon to use. Let's draw a triangle here, and let's draw another triangle here. Okay? Now, go ahead and draw these two triangles, please. I'm not going to use numbers, I'm going to use symbols. Let's say this angle here is congruent to this angle here. Let's say this angle here is congruent to this angle here. And let's say this angle here is congruent to this angle here. Okay? Now, I'm going to go ahead and call this side here 4. Write that down, please. I'm going to call this side 5. And this side here is 6. Okay? Now, over here I'm going to call this side 2. Not call it, but the length of the side is 2. The length of the side here is 3. And this side is 2.5. Now, remember the symbol for congruent is like this. Well, here's the symbol for similar, and you need to know it. It's this. Let's go ahead and give this triangle a name. A, B, C, D, E, F. Go ahead and copy that down too. I'm going to pause for about 10 seconds while you guys quickly finish copying all this down. It's very important you have all of this in your notes. Okay, students, now here's why these two triangles are similar. First of all, notice they have congruent angles, corresponding congruent angles. This angle is congruent to this angle. This angle is congruent to this angle. And this angle is congruent to this angle. That's step 1. You must have both of these things. You must have congruent angles, and you must have proportional sides. So step 1 is checking the congruent sides, congruent angles, and we do have congruent angles. Next, we must have proportional sides. Now, key word here is corresponding proportional sides. In other words, this side here, now watch carefully what I do. Please, students, take good notes on this. This side here is the side that has 1 mark and 2 marks. And this side over here is the 1 mark and 2 marks. So 4 corresponds with 2. So I'm going to put 4 over 2. Okay? 4 over 2. That's easy. Now look at this side here. 6 right here. 6 is the side that has a 1 mark here and a 3 mark here. So what side over here has 1 mark and 3 marks? This side here. So 6 goes with 3. So I'm going to put 6 over 3. Now, 5 corresponds with 2.5. So I'm going to put 5 over 2.5. Now watch what happens. If I reduce all 3 of these fractions, and I do not get out the same fraction for all 3, then these two triangles are not similar. They are not. reduce all three fractions and I get the same fraction, then yes, it is. These two triangles are similar. So 4 over 2 reduces to 2 over 1, or just 2. 6 over 3 reduces to 2 over 1, or just 2. And 5 over 2.5 does reduce to 2 over 1, or just 2. So are all three fractions the same? Yes, they are. So let's review. Did I have congruent angles from one triangle to the other? Yes, I did. All of them. Did I check every single corresponding side? Yes, I did. Are all the corresponding side ratios congruent? Yes, they are. So these two triangles are similar. That's what we mean when we say the corresponding sides must be proportional. That means when you line up a side with its corresponding side and you list them all out and you reduce them, you better get the same fraction out. Okay, so that's why these two fractions here are similar, congruent angles and proportional sides. Okay, please understand that. All right, moving on. Now let's move on and talk about what a scale factor is. It's very important you understand this. Okay, instead of giving you a definition, let me just give you an example. Okay, let's go ahead and use a rectangle here. So we're going to draw a rectangle that looks like this, and a rectangle that looks like this. Okay, and we're going to say these two rectangles are similar. Now copy all this down, please. I'm going to say this side here. Oh, you know what, guys? I forgot to tell you something really, really important. Please accept my apology. Let's go back here. I want you to be able to write a similar statement. Remember how you used to write congruent statements? Well, now I want you to write similarity statements. So, triangle ABC. Now look, I don't care if you call it ABC, ACB, BAC, BCA, CAB, or CBA. It doesn't matter. I'm going to put triangle ABC. Triangle ABC is similar to triangle. Now be careful. You put A first. A has 2 marks. Which angle has 2 marks over here? E. B is second. B has 1 mark. Which angle has 1 mark? D. And of course the only letter left is F. That's called a congruent. That's called a similarity statement. Okay? Or a statement of proportionality. Sometimes it's also called. Okay? A statement of proportionality or a congruent statement. So students, copy this down. Make sure you understand that. All right? Okay, and this really should be pretty familiar. We've looked at a lot of those things when it comes to congruent triangles, so it's very similar. Okay, no pun intended. All right, now let's talk about this scale factor thing. You really need to understand this. Okay, we're going to call this rectangle ABCD. I would copy that down if I were you. It does matter. And rectangle EFGH. Now watch what I do here. If I asked you this question, now watch carefully. If I said, sorry for yawning, guys, excuse me, if I said, what is the scale factor of, now write this down please, what is the scale factor of rectangle ABCD to rectangle EFGH? Well, here's what you do. Let's pretend this side here had a length of 7, and this side over here had a length of 3. Okay? What is the scale factor of rectangle ABCD to rectangle EFGH? Well, which rectangle came first up here in the question? ABCD did. ABCD did. So you start with ABCD, and you take one of the sides. It doesn't matter which one. I'm going to use this one because it has a number, okay? And you put that number right here. Then you put a fraction. What rectangle came second? This one did. So you come over here and find the side that corresponds with 7, 3, and put it here. And you're finished. It's that easy. Unless you can reduce the fraction. If you can reduce the fraction, then you must reduce it. So what is the scale factor of ABCD to EFGH? 7/3. Now, hold on a second, students. Please take good notes. Please pay attention. What if I said this? That's not going to work. What if I said What is the scale factor of EFGH to ABCD? Now it's going to be a little different answer. Which rectangle came first in my question here? EFGH. So I start with this number first, 3. Which rectangle came second? ABCD. So this number goes to the bottom. So instead of 7/3, now what is the scale factor of rectangle EFGH to rectangle ABCD? 3 sevens. 3 sevens. So it does matter which one you put on top, and it does matter which rectangle comes first in the question. So make sure you understand that. This is what a scale factor is. Okay? It's showing the relationship between the two sides. Alright, let's continue on. Now, we're going to take a look at a theorem that talks about the ratio of perimeters of similar polygons. Okay? So watch this carefully. Please copy this down. You're responsible for this. If two polygons are similar, then the ratio of their perimeters is equal. It's the same as the ratio of their sides. Copy that down. You're responsible for that definition, or that theorem, excuse me. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. Let me give an example of this so you understand what's going on, okay? Here we go. Let's go ahead and use some triangles again. Let's see, we'll draw a right triangle. And a bigger right triangle. Alright. Let's label this right triangle 3, 4, 5. And even though I don't know the angles, we're going to pretend they're similar. I'm going to go ahead and do this. We're going to say they are similar, okay? Let's put call this 12, call this 15, call this 9. Now, trust me, the two triangles are similar. Now, watch this carefully. What if I asked you what the ratio is of their sides? Well, you would say 4/12, or 5/15, or 3/9. So 4/12 would be the ratio of the corresponding sides, which would reduce to what? 1/3. Now watch this. Find the perimeter of this triangle. 12. 4 plus 5 plus 3. Find the perimeter of this triangle. 36. Okay? Now, we've been going from this triangle to this triangle. We took the 4 first, and the 12 second, and the 12's on the bottom. So let's do the same thing with the perimeters. The perimeter for this triangle here goes up top, and the perimeter of this triangle goes to the bottom. And look at that. If you reduce that, you get what? 1/3, which is the exact same scale factor, or ratio that we had of corresponding sides. Okay? So let's go over this again. Whenever polygons are similar, the ratio of their corresponding sides will be identical, the exact same as the ratio of their perimeters. Okay, continuing on. Now let's apply some of this knowledge to some problems. And some of these problems here are going to be challenging, so really pay attention. Before I tell you what we're doing, just go ahead and copy this down quickly. Write down these ratios: 2 to 3 to 4, 6 to 6 to 8, 5 to 5 to 5, 3 to 4 to 5, and then copy these down also, okay? So go ahead and copy all this down, and then we'll go ahead and I'll tell you what I would like you to do. So please go ahead and copy these down. Now, students, please take some really good notes. I'm going to be honest with you. These directions will be a little confusing, but if you'll pay attention, I think you'll be okay. Alright, so here we go. What I want you to do is I want you to realize these are ratios of triangles. So if you want to make note of that, feel free to. Ratios of triangles. Okay? Now, what we're going to do is we're going to match up one of these ratios here with a ratio over here that shows this triangle here is similar to a triangle over here. We're going to assume all the angles are congruent of the triangles. Okay? So we're looking for proportional sides. Now, I'm going to go through and pick some easy ones first. Look at this. If I have 6, 6, 8, I'm looking for a scenario over here that's the first two numbers that are the same, but not all three. Well, 3, 3, 4. So I'm claiming that these two triangles here are proportional? Let's see. I would have 6 over 3. 6 over 3. 8 over 4. Yep, I get 2 over 1, 2 over 1, 2. Another way to look at it is like this, guys. You went from 6 to 3. So you divide it by 2. So 6 divided by 2 is 3. 6 divided by 2 is 3. 8 divided by 2 is 4. So we all use the same number. Now, look, here's 3 5s, and I see 3 4s over here. Let's see if this could work. And of course it does, because you have 5 over 4. 5 over 4. And 5 over 4. If you reduce, well, you can't reduce those fractions. So we got the same fraction for all three. So this triangle here and this triangle here are similar. Let's take a look at this one here. 2, 3, 4. Now, let's see 2. There's a 2 here, right? And a 6 here. So let's take, that'd be what? 2 times 3, right? So 2 times 3 is 6. So 3 times 3 would be 9. And look, do we have a 9 here? No, we do not. So that's the wrong one. So let's try this one right here now. I'm going to go ahead and draw a line. Okay, we went from 2 to 4. So we took the 2, we multiplied it by what? By 2. So 2 times 2 is 4. Now take the 3 and multiply it by 2. We get 6. Take the 4 and multiply it by 2. We get 8. So we multiplied each number by the same number. So yes, those two triangles are proportional. Now, here's my last one from here up to here. Now watch this carefully, okay? I went from 3 to 6, which means I'm multiplying by 2. So 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. Okay? So what we're doing is kind of teaching you here how to match up proportional triangles or polygons with proportional polygons. Okay? Alright, let's continue on to another page here. Now, take a second and copy down these two parallelograms, okay? And we are told they are similar. So make sure you make note of that, okay? I'll give you just a minute. Please copy down these parallelograms. Okay, let's go ahead and continue on. If you're not done, copy these down. Go ahead and keep working on that while I'm talking. Now, I want you to find the length of EH. Now, guys, we just learned how to use proportions and ratios in the last two lessons in this chapter. So let's continue on. These two parallelograms are congruent. Okay, and they are parallelograms, by the way. I should have said that too. These are parallelograms, both of them. Now, if these two parallelograms are truly similar, then we can match up this side here with this side here. So I'm going to say 6 over 3 equals, now they want us to find the length of EH. Now this side here corresponds with this side here. No, not at all. This side here corresponds with this side here, which is 4. So I could say 6 over 3 corresponding sides equals 4 over EH. Segment EH. Now let's cross multiply. 3 times 4 is 12. 6 times EH is 6 EH. Divide by 6. 2 equals EH. So there's the length of EH. 2. Now next they want us to find the measure of angle G. Now remember, whenever two polygons are similar, then we know their angles have to be congruent, and that's why they're giving us this problem here. Think about that. So I know I have parallelograms, which means consecutive angles in a parallelogram are always supplementary. So if this is 30, then this has to be 150, because 30 plus 150 is 180. Now remember, in parallelograms, diagonal or opposite angles are congruent. So if this is 30 here, this has to be 30 over here. If this is 150 here, this has to be 150 here also. Okay, so find the measure of angle G. Well, angle G would correspond with angle C. So angle G would be 150 degrees. it shouldn't be too hard. We know a parallelogram always has opposite sides congruent. So if this is 3, this is 3. Remember, we went from 6 to 3, which means we divided it in half. So from 4 to here is going to be 2. Take your 4 and divide it in half, and you will get 2. And if this is 2, this is 2 over here. Because in a parallelogram, opposite sides are congruent. So we have 4, 7, 10. So the perimeter of EFGH would be 10. Okay? Alright. Guys, I hope this video has been a help to you. If you have any questions, don't hesitate